Hello, I'm Adam Fletcher. Sorry that Google is not expanding to full screen, that's fine. I'm here to talk about what systems are involved when you search for a flight, when you book a flight, when you depart on a flight, and I'll talk a little bit about some of the protocols that those systems use to communicate with one another. And I'm also going to cover some of the history of computers and airlines. You should believe the things I'm going to say because I built airline reservation systems for 5 years with ITA Software and with Google. And in this time, I touched basically every non-airplane system involved in getting passengers from here to there, with the exceptions of the weights and balance system. I didn't write any software that could cause a plane to crash, but I did write a lot of software that could cause you lots of delays at the airport. And I'm excited about systems we love. I love that humans learn to fly. Like, I think that's truly, truly amazing. Like, I look up at my wife will tell you, I look up at the sky and I'm like, I can't believe that plane is flying, right? And I'm so proud to have worked on some of the systems that helps that happen, and I'm happy to be able to talk about it here. First, a little history. Booking a flight before, say, the 1960s looked kind of like this. You would make a phone call or you would send a telegram via Western Union and say, like, I want to fly somewhere, and then a bunch of people in a room would stand up at a big board and write cards and move them around. And this worked pretty well. Not a lot of people were flying at the time, largely because it was very expensive. And it was a very regulated industry, so airline flight costs were fixed. And also, it was kind of scary to fly then. People weren't really used to it. Airlines were very early adopters of computer systems. I mean, really early, right? So in the 1950s, IBM had built a system called Sage, and they used this to track potential nuclear threats to America. And the system involved tracking many objects. It involved people, planes, missiles, various statuses, such as like inventory at bases, involved tracking radar signals and things like that. And this was built, like I said, in the 1950s. You can actually go to the Computer Museum, which is in Mountain View, which is about 4.5 hours by car south of here. It turns out that airline reservation systems are basically the same problem as Sage. So you need to track planes, people, inventory, signals, people's stuff, et cetera. And the anecdote is that a vice president at American Airlines was flying on one of their planes, and an executive at IBM was sitting next to them, and the IBM executive was talking about Sage and how it worked. And the AA, the American Airlines executive, thought, oh, I could use that to handle all my bookings and to handle all my management of all of my airline, right? And from there, IBM was contracted with building Sabre, the first airline reservation system. And Sabre really had some truly amazing technologies for the time. And the time was the 1960s, right? And so it had distributed databases, or you had multiple computers that interacted here. It had networking that was both synchronous and asynchronous networking, right? Store and forward, fire and forget. It had database schemas, complicated database schemas, well before we had the idea of like normal forms and things like that. Predictable and measurable performance of transactions. And this was all, like I said, the 1960s, really amazing. Now, unfortunately, very little has changed in the airline reservation system market since then. But it is amazing that these programmers solved like these enormous, huge problems at a time when there were probably less than 100 computers in the entire world, right? And we still fight with these problems today. Like if you look at Hacker News, everyone is arguing about some distributed systems problem, right? Or Lisp. This timeline shown here. The timeline shown here on the left is the history of Sabre. This is sort of just the history of things that have come out of Sabre, but it's also, if you work in the industry, you know this also maps to the Sabre code base, right? The modern reservation systems are largely sprung from the original Sabre code base, updated and modernized for the IBM 360 mainframes and their children. Not much has changed since then. There is a lot of more fascinating stuff that happens in the history of the airlines and computing, in particular deregulation in the 70s and 80s. You should read a book called Hard Landing about it. I'll show you in the last slide. There's a citation for it. But let's talk about what happens about when you want to fly, right? Let's say you want to fly nonstop from San Francisco to Boston. How does this happen? Let's say you want it to be under $500. Right? The very first thing is you need to know is if any airline actually flies from San Francisco to Boston, right? It seems self-evident, of course, but you need to decide also when you will fly, like what dates, what times you want to fly. So the way searching for a flight was done before computers got involved is there was a big book, conveniently called a schedule, which is a good name for a schedule, And it was published a few times a year. And you would go to a travel agent and be like, I want to fly to Boston. And the travel agent would open the book for the Boston section. And then they would just point right at the very first line, the very, very first line, because they were humans and they didn't want to keep looking, right? And then that's what you would fly. But after that airline deregulation in the 70s and 80s, airlines were free to set prices pretty aggressively. And American Airlines, which owned Sabre at the time, would rent out terminals to travel agents that they would put in their offices, and they would have computer access to the reservation system. And now they could search for flights. And so what they did then was they would search for a flight, and then they would look at the very first line, the very first screen, and they would give you that flight, right? It's exactly the same thing, right? And what's interesting now is, today you do it a little differently. Today you use what we call online travel agents, or OTAs. This is like Orbitz, Expedia, Google Flights, right? And you do the searching there. Now, the schedules are created in the same way. They're actually created by the airlines themselves and pushed to a schedule clearinghouse. That schedule clearinghouse will then send those schedules to anyone who wants to give them money. And you can get all the schedules. Now, the schedules are just the schedules. They're just the flights here. And they're in a fixed format file called the Standard Schedule Information Manual. And it's easy to get. You can buy it. The fares are not associated with that yet. The fares come from a different clearinghouse, and they're also published by the airlines and pushed to that clearinghouse. Now, the fares are the price, and they're also this thing called the fare rules. And those are the rules that go along with the price. These are the things that determine whether you can resell the ticket or whether you can rebook or how much it's going to cost. Let's look at these rules. These rules are very complex. You don't bother reading this. You're not supposed to read this. This is just an example. There are 340 more lines to this that I don't show you. Fare rules are fascinatingly Turing complete. Why not? There is also, inside the fare rules, deep in the bowels of the fare rules, there are fascinating things about, when you can fly. Let's say you have an infant who's under 2. They have to go on your lap. They're free. But if you cross the international date line, their age changes. Do you have to pay for that? Sometimes you do. Or whether or not, if you're transporting a human organ, does it need a seat or not? If you have what's called a meat trophy, which is like a hunting trophy, if it's a salmon, you can carry it with you. If it's half a moose carcass, you have to put it in the overhead. These are all real examples of things in fare rules that I have seen. Now, okay, so back to the search, right? So in the early 80s and well into the 90s, search was, like I said, it was basically linear. You flip through the thing and you see what you get, right? And it heavily gamed, literally heavily gamed in favor of whomever was provided the terminals to travel agents, right? Then in the late 90s, some MIT kids decided to apply computer science to the problem of searching for schedules, fares, and figured out that search was really, 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 really hard. And when I mean hard, again, don't bother reading the slides. It's just wicked hard. It's unsolvable hard, capital H hard, big O notation, your complexity and computability class hard, right? You can read, this paper is excellent, Carl DeMarkin's paper. I have a citation there, and I'll have it at the last slide. You should read it, it's fascinating, but suffice to say, really hard. And this complexity is a side effect of the technological and economic arms race between the airlines. For example, that terminal that American Airlines provided to all the travel agents, American controlled that. And what they didn't do was let, say, Eastern Airlines put any of their flights in it. And what happened then is Eastern Airlines went bankrupt, right? They had no way to get to the customer. And these got more and more complex. Those fare rules were used in this. And so all of those things, the schedules, the fares, the fare rules all add up to very complicated, unsolvable search. However, with a lot of Lisp code and about 60 wall clock seconds of CPU time, these kids got pretty good answers, and they started a company called ITA Software. The paper I took these from, again, like I said, is on the internet, and you can go into that. And for a long time, ITA was the largest employer of Lisp hackers in the world. Back to our flight. So we're starting to see some more of the systems involved here. There's you, the browser up there. There's orbitz.com or whatever your OTA is. And down in the corner in this purple box is QPX. That's the software that ITA built. It can be some analog. There's other ones that search. In order to search, you need some information. You need, like I said, the schedules and the fares. Those are published from those clearinghouses. You also need to know if there's inventory available on the plane, and you need to know if you have availability. And I'm going to talk a little bit more about that, right? Because now we know the flight we want, but we don't know if we can book it, right? And before you can book it, you need a seat. And actually, seats are controlled by this thing, the inventory control system. And that should be the count. Inventory sounds like it should be the count of how many seats are available on the plane, and indeed it kind of is. And what's happening when you're booking is that when you select some seats, you're sending a message out to an airline reservation system saying like, hey, I might book these seats. Can you hold on to them for like 15 seconds? This is like the Ticketmaster timer. You know, your tickets are yours for 15 minutes. This actually happens behind your back when you're booking. And if you don't book those, they just get freed back into the pool. So let's try to book. And so maybe if we try to book, we get lucky and we get 2 seats. But why are we lucky? And we are lucky because the airline has told us that it will sell us the seat. The airline doesn't actually care about how many seats are available on the plane. This is like useless information to them. They don't actually care. What they are doing is they use this thing called availability to control their willingness at any point in time to sell you a seat at a certain fare class. And availability is the magic. So availability is like an ever-changing stream of messages that say things like, I will happily sell 2 seats at booking class Y, 9+ seats at booking class I, et cetera, et cetera. And then 10 seconds later, they send a message that says exactly the opposite things, right? And that's their willingness to sell. And that is actually how they control, how they change prices and control what's available on a plane. And they do this very fast, like 100 hertz. You get messages for this sort of thing. And there's a system called the revenue management system, which is it's a system, but it's a bunch of humans and computers that model what they should charge and how much they should charge and what seats they should make available. And you can imagine this sort of makes sense. If you live in New England and you want to fly to Florida in the middle of February because it's freezing in New England, right? If you booked it months in advance, maybe it's one price, and if you're booking it like the day before you want to fly, they obviously want to make that price different. And it gets way more complicated than that. This is why the person sitting next to you paid a completely different amount for the seat. All right, so we're lucky. We got some seats. So now we can book our flight. You book your flight. That's great. You get a confirmation code. Let's say your confirmation code is FXN91G. Doesn't really matter. Some 6-character code. What does booked mean? When I say you booked your flight, what does booked mean? Booked means you have now a passenger name record, which is all the information about you and your itinerary. You were issued e-tickets, which are the ticket indicators. And that confirmation code, we also call it our record locator. On this box, you'll notice a few things. On this diagram, you'll notice a few things have changed. One, we have a brand new red box, the GDS, that's up there, and I'll talk about that in a second. And then we have a reservation system on the right, and the reservation system is the canonical source for all of these things. It is where inventory is set, it's where the tickets are stored, where your reservation is stored, where the schedules are generated, where the fares are generated, and so on. The GDS, the global distribution system, which is what Sabre is now. Sabre is also still a reservation system provider. The GDS is basically a clearinghouse. Let's say if you wanted to fly from San Francisco to Tanzania, maybe no one airline does that. And the GDS will broker all the transactions between all those airlines, but make it appear as if there's only a single airline that give you a single confirmation code. One fascinating thing about the reservation systems and the GDSs actually is they are basically IBM and HP mainframe or HP mainframes. They have 100% yearly uptimes. Some of them have multiple years of 100% of yearly uptime. So they have no 9s, but they don't need them. If the systems go down, the backup and restore strategies are often, well, we have lots of planes, so why don't we just put some tapes on a plane, fly that plane to the place where our other mainframe is, and load those tapes up. Now, if it's down for more than 24 hours, it can be really bad. Airlines are cash poor. Like an airline will go bankrupt if they don't fly planes in 24 hours easily. And that actually might be good for the airline to go bankrupt. The airlines actually like going tactically bankrupt because it helps them invalidate labor contracts and things like that. So like you might be great. Richard Branson once said the best way to become a millionaire is to start as a billionaire and buy an airline. The other thing is the mainframes are actually really nice. They're super predictable. So you know things on a mainframe, like you know exactly how many CPU cycles every transaction costs you. You know exactly how many milliseconds each transaction is. And that's actually really neat. One other interesting bit before we leave this slide is that confirmation code, FXN91G, it's a 6-character string. Why is it that? Because in the early days, that was the block address on a disk where your PNR lived. So literally, they just printed a pointer out and gave it to you. Which, I mean, is great, right? Okay, let's look. Before we get to the last few systems that you're gonna interact with, let's talk about the system, how they communicate, because I think this is also a hilarious moment. Much thanks to my friend Kos, who quoted this: "Rejected messages will not be rejected." That is from a communications manual. Don't know where they go, but it was really awesome in the 60s that Sabre was able to build these really cool technology, asynchronous messaging, synchronous messaging, store and forward, et cetera. It's not awesome that they still basically use the same technology and the same protocols for inter-airline system communication. Airline systems can communicate over TCP/IP. They often do, more often now than not. If you grep your Etsy services, you will see MATIP is on several well-known ports, which is super cool. MATIP is basically just a container for airline messages. On top of that, you can have a bunch of things. You can have another thing called BATEP, which is a different container for airline messages, which has a nice RFC, and it uses the lovely RFC mapping to well-known ports trick. On top of that, you get the best things. You get Edifact, which is a standard that's like XML but worse. Sometimes they wrap Edifact in XML, and there's a standard for that too. That's the worst. And then Teletype is free text. It's like Teletype. Now, airlines, in fact, use Teletype so often that some agents will have Teletype addresses that they use as if email. They send that between computers, and computers are supposed to know what each Teletype message means. There are some standards for that. There's not really a great standard for that. Largely, the way you figure out what the Teletype messages mean is you get on the phone with someone else at another airline. You said, "I've sent you a Teletype message that is a request for inventory. What did your computer think it meant?" And sometimes you wrap Edifact in Teletype. Sometimes you get Teletype messages that start out at ASCII and turn into EBCDIC and then turn back into ASCII. So you have a lot of fun when you do that. At the break, I can talk to you about the amazing security implications of all of this, but not right here. Okay, so that's how the systems talk. Where is your data? Who has your data? That's a great question. So you have a record locator. That's your confirmation code. The online travel agent also has a copy of that. A bunch of people have your credit card. So be it. Your PNR and your e-ticket, that passenger name record and your e-ticket, that's stored in the GDS, the res system. And then we're going to talk about a system called departure control in a second. That's where that lives. The Department of Homeland Security gets a copy of all this many times. Okay, but back to your flight. It's a few days before you depart. What's happening? Okay, so when it is 3 days before, when it's within 3 days of your departure, 72 hours, you get put in what's called the departure control window. This means that a lot more things start to happen around you, the actual act of you flying, right? So another thing, it assigns you what the airlines call equipment. Equipment is your plane or other things associated with it. It gives your flight details to the airport, to flight status websites, and so on and so forth. It figures out the weights and balances when you get to within a few hours of your flight. The airport gets a gate for you to be at, which is really nice. Many things can screw up your flight. Like I said, weather, equipment failure, pilot strikes, airlines going bankrupt by accident, airlines going bankrupt on purpose, the price of oil changing, all these things happen. The term of art for those is IROP, irregular operation. When an IROP happens, you get what's called reaccommodated. Reaccommodated is awful. That means you get moved to a different flight. And it's not awful for any reason except for that the tools available in modern airline reservation systems, which are not actually modern, are terrible for this sort of thing. Finally, the time arrives for your flight. You can board and you can fly. Now, as you're flying, a few other state changes are happening. That particular ticket, your e-ticket, as part of the PNR, is being marked as flown. And various systems get updated on it. And finally, welcome to Logan Airport in Boston, Massachusetts. You've completed half your trip. You've interacted with some of the most reliable, fastest, and oldest computer systems in the world. And don't forget, like, you flew in the air. Like, you went in the air. That's amazing, right? Cool, thank you. Ask me questions at the break. I will answer some common questions. You cannot predict fares by looking at historical fares. You should find fares on ITA Matrix. Can't book there, though. And it's generally cheaper to book on the airline's website. Everyone asks me all those questions, so I'll answer them. And then at the break, find me if you have any more interesting airline questions. Thank you very much.